No response. What have we learned in the previous lecture?
Ada yang encapsulated ya, Madam.
Basic terminologies.
Yes. Yes. What are the 6 basic terminologies that you have already learned? Just now you mentioned encapsulation. Another 5, what is it?
Class, inheritance,
Class, inheritance,
description,
yes,
object,
object,
polymorphism.
abstraction. Yes, yes. So those are all the basic terminologies that we have seen, right? Hold on, ah. Because I seeing people coming in, I want to unlock the meeting for a while. I don't know how it become locked. Okay, can you see the slide?
Yes, Madam.
Yes, madam.
Yes, madam.
All right. So those are the 6 basic terminologies that you have already roughly seen. Today we are going to look into more detail of what are those terminologies about. Okay. In this chapter, we are going to be able to define object, what are object, attributes, and behavior. You are also being able to explain object-oriented concept terminologies, the 6 terminologies that we have already seen last week, and then to identify the notation that is used for object-oriented analysis design. So remember what is object-oriented analysis and design? We have already seen also, right? Okay, how are we going to identify it? By using UML, describe general UML elements, class diagrams, and also design classes using class diagram. Okay. Firstly, we're going to look into what is object, and then what are the relationship in between object attributes and the behavior. Object is actually an abstraction of something in a problem domain, reflecting the capabilities of the system to keep information about it, interact with it, or both. So keep information about it is eventually about the data. It is the data or the properties of the object, and interact with it means that the function, methods, or behavior of the object. Okay, so when I say data, automatically you would think of noun, kata nama. When we say about behavior, interact with it, or the method, operation, behavior, this one will be the verb. Another word for it is kata kerja. Objects are entities in a software system which represent instances of a real world and system entities. Object-oriented programming make and use objects, of course, because it is an object-oriented programming. It uses object. What does object has? Object has data members, or another word for it is attribute. Another word for attribute is variable. It also has function members, another word for it, behavior or method. The program can tell an object to carry out one of its methods. Okay? Attribute is information about the object. For example, an object pen. Blue color is the information of the pen. Okay, when I say blue color pen, automatically you know that it is a blue pen. But when I tell you it's a pen, you have no idea. It is just a general thing, a pen. But when I say Pilot brand, blue color, and 0.7 size pen, so you know exactly what pen is that. Okay, so that is the attribute of the object. The attribute has a type. It defines the type of the instances. only object that is able to change the value of its own attribute. For example, your an object is an SPMP. Student name can be Nuriwati, for example. You can only change the detail of yourself, correct or not? You cannot change the detail of your friends. So only object is able to change the value of its own attribute. The set of attribute values defines the set of the object. Okay. Behavior is the implementation of a service that can be requested from any object of a given class. It can describe how the object behaves, what the object can do or carry out. This is the example. Student object. Okay. You know that the student name is Tax. He lives in Helsinki. His major is CSE. Course list that he registered for that semester is D3. But class student, class is a more general. When I say student, you don't know what is the name, you don't know where is the address, you don't know. But you know that it has these attributes, just that specifically you don't know who, you don't know where, you don't know what. Okay? But for object, you know exactly this student refer to Tax. You know that this student stay at Helsinki. So that's the difference in between object and class. That is why you said that class is actually the blueprint of object. In object, in this object, it has name, it has address, it has major, it has course list. So what does student object can do? It can change the major, it can add course, it can drop course. So this is the behavior of this object. It derived from the class. Any question? No question, I proceed,
Madam.
Yes,
No, madam.
what is it?
No question, no question.
Oh, no question, all right. I proceed, Very straightforward, You have to remember, class is a general structure. It's like a template. You know that inside class, it has these variables. It has this data, but you don't know exactly what is the data. Okay, you know that it has this function. It can carry out this function. Okay, but in object, it is specific. You know this student's name is Tax. You know the address is what. So this is specifically addressing one student. Okay, it can be another student, maybe name Nafrizal. The address is Kuching, for example. The major is DDT. The course list, one of it is DFC 300123, for example. So that is object. It carries data. But class, it shows you only the general structure. That is the difference in between class and object. Okay, are you familiar with this?
Yes.
Yes, we have already seen this in the first chapter previously. Okay, so this class is actually combination of variables collection from various data type and related function. This is another example for class. You have rectangle. Okay, inside rectangle, it has length and height as the variables. It has calculate area, calculate perimeter as the function. Okay, the definition for class is combination of variables, collection from various data type, and related functions. Okay. For your information, this is a class diagram. You have to be very specific. The first row is class name. Second row is variables. Third row is function. This is the format, this is the syntax for class diagram. You have to remember, first row is the name, class name. Okay. I have to draw. First row is what class?
Class name.
Second row,
Variable names, a variable.
okay.
And
Third row,
function.
Function.
okay. So it is fixed. You cannot put function in the second row. It's wrong, okay. Third row is,
Functions.
how do you know that it's a function? How do you know that this is a function?
Because of the bracket.
Yes, you identify the brackets, okay? And then inside the bracket, it has parameters, okay? So this is fixed. You have to remember the syntax. Next, object. What is object? It's an instance of class, okay? It is derived from a class, so it is an instance of class. It is a component of a program that knows how to perform certain action to interact with other pieces of the program. It's the actual thing that can be manipulated. A person is a class. Sophia is the object. When I say person, you don't know which specific person is that, then the general structure, that is a class. But when I say Sophia, it is obvious that it points to Sophia. You know that it's derived from person. Sophia is a person. So that is object. When I say object, it specifically point or it's specifically having certain value already. Okay? Inheritance is the ability to define a new specialized class from an existing class. What is existing class? It's actually the parent class. You must have the parent class exist first, then you can derive a new specialized class, or another name for it is a child class. Okay. If you want to inherit from somebody, that somebody must exist first, right? If you want to inherit curly hair from your parents have to exist first, then have you. Okay. Subclasses are more specialized version of a class which inherit attributes and behavior from the parent. Can introduce their own. That is inheritance. Any question?
No, madam. So far, so good.
It's a revision from the previous class. Next, abstraction. Data abstraction refers to the concept of representing only the essential feature of a data without including the non-essential complex details. For example, consider a car object. A person can drive a car without knowing the complex detail about the engine, braking, gear mechanism, and so on. But you know that if you want the car to move, you step on the pedal. That is abstraction. You know the feature, but you don't know how it works behind there. You don't know the essential detail, but you know the feature. That is abstraction. Abstraction concept helps programmer to concentrate on the essential detail. Polymorphism is the ability of object from different class relating by inheritance and give separate response towards the same message, or an object belonging to different data types responding the calls of method of the same type, each one according to appropriate type specific behavior. Look at this example. What do you notice that is same here? What do you notice that is same here? Anybody?
Same function, madam.
Yes. What is it? What is the name?
Add.
Add. Okay, correct. So the polymorphism concept is you're having the same name, but then you are doing different things. Okay, what different thing are you doing here? Okay, hold on. Can you see my screen?
Yes, madam.
Okay. Can you see I highlight something?
Yes,
Yes.
madam.
Can you see this?
Yes, madam.
Yes, madam.
Both function is actually adding up something, right? So this function, it adds up two integer number. Let's add. Let's say s is 5, y is 2. So you add up, it becomes 7. That is add. The second function is also add. But what does it do? It concatenate two string. It combine two string. Let's say S is hello, T is world. So it combine hello and world. It will produce hello world. Understand? But they are using the same name, add, doing different things. Can you see that?
Yes, madam.
That is polymorphism. Okay, it has the same name but doing different things. It responds to different calls of method. If you are calling it using integer, it will call this function. If you call using string, it will come to this function. That is polymorphism. Okay. Next, encapsulation. It is the process of combining data and functions into a single unit called class. Using the method of encapsulation, programmer cannot directly accessing the data. Data is only accessible from the function present inside the class. Okay, that is encapsulation. Remember the capsule?
Yes, the medicine.
Yes. So that is about terminology of object-oriented programming. Next, let us look into UML. What is UML? UML is Unified Modeling Language. It is a graphical language for visualizing, specifying, constructing, documenting the artifact of software-intensive system. Okay, before you build a house, what do you do first?
Draw the blueprint.
Yes, you have the architect to design the building structure, how big is the house, how many rooms, do you have car porch or not, and so on. Before you build a software, UML is actually the blueprint to help you to build out the software, to specify your software, to document it. It's like the blueprint for you to build a building. Okay? These are some of the UML, but not limited to these 7. There are more. This is just some of the example that I list down for you to refer. There are more. Okay, we have use case diagram, activity diagram, class diagram, component diagram, sequence diagram, state diagram, package diagram. We have also object diagram, and so on. Many more. You can Google later on. Okay? Today we will look into use case and also class diagram. These are the general structure. Use case, it looks like this. Oval is a sequence of action including variants that a system or other entity can perform, interact with the actor of the system. So this is the actor or the user that is directly or indirectly related with the use case. We have the system boundary. It shows the boundary or the scope of the physical system. Association, the relationship. Generalization is for the, normally is for inheritance. Okay, extend. We also have the include relationship. Okay, this one you have to remember the syntax lah. Later on you will see how it used. I will show you by example. Use case diagram is actually a diagram that shows the relationship among actors and use case within the system. It provides overview of all parts of usage of the requirements of a system or organization in the form of essential model or business model. It has the communication of the scope of a development project. model the analysis of the usage requirement in the form of system use case model. This is how it looks like, but it's not so correct. And let us correct it. Remember the boundary of the system looks like rectangle. The boundary of the system. Okay, so this system is an medical appointment system. Before the patient want to see the doctor, so they will make appointment first. They will request for a appointment. These are the actors that is directly or indirectly related with the system. We have the patient. What patient can do? So you see this oval syntax is actually use case. Remember? What is use case? Use case is the sequence of action that can be performed by this system. What this system can do? It can cancel appointment, make appointment, request for medication, pay bill. Remember, this is a system. Click a button to cancel appointment. Who can do that? Scheduler can do that. Patient can do that. Patient can make appointment. Patient can request for medication. Doctor also can, but not scheduler. Scheduler is only the clerk or the person that can help you to make appointment or cancel appointment. This clerk is the accounting clerk that help you to manage your paying bill use case. So this is an example of use case diagram. It's very straightforward. You just have to identify what are the use cases, who can do what, and then you have to identify also the boundary of the system. So this is a use case diagram. All right. Class diagram. This is the most important part of our lecture. This one you must be very, very concentrate because this one is like the heart of your object-oriented programming course. Okay. What is a class diagram? It shows the classes in the system, their interrelationships, and the operation and attributes of the classes. Operations here means that the function. Attribute can be the variables, remember? Class diagram are typically used to explore domain concept in the form of domain model. You identify what are the classes that you are going to build. In Java, we call the code as class because you actually designing class. Okay, analyze requirement in the form of a conceptual or analysis model. Depict the detailed design of object-oriented or object-based software. Class diagram has the following elements. We have the classes. How does class diagram looks like? How many rows just now? Remember? Cheryl, how many rows do we have in class diagram? How many rows? Do you remember? Just now we look at a table and then we have the variables, we have the function, we have the class name. That is the class diagram. How many rows do we have? Remember or not?
3.
Yes, 3 rows. The class name, variables, and also the function. Okay. For the associations, means that the relationship between 2 or more classes. 2 or more classes. Let us see how does class diagram looks like. You see, all the classes here only have 3 rows. 1, 2, 3. 1, 2, 3. All the classes here has only 3 rows, but it has the relationship in between. Okay, this is inheritance. This is aggregation, association, and so on. That one we'll learn in chapter number 4. Okay, but now you have to identify what are the elements within the class, what the component inside class with the class name, attributes, operation. Okay, can be related with each other. So now this is the component of a class. It contains field or variables or attribute, and also methods, okay, or function. From here, from this class diagram, eventually you can transform it into Java code. So for your information, this is a Java code. First row, you have to declare class. This is the keyword class name. Okay, this is what we say class declaration. Okay, this is a float, sorry. Next, you see here there is a variable A, float type. So you declare float A. This is what we say variable declaration. But this one is not inside the class diagram. Can I declare or not? Yes, the answer is yes, because this is just a blueprint, a template for you to refer. So if along the way, when you develop your code, you think that there is a need for you to declare a new variable, so you declare one. Next, function declaration. So you declare function here. Understand? Understand or not, class?
Yes, madam.
Yes, madam.
After this, you have to do, okay? You have to, if I give you class diagram, you should be able to write it to codes. It's actually very straightforward. Okay? From here, this is a class diagram. You can actually derive into Java code. This is Java code. If in programming fundamental, you will use hash include, correct or not, to start your program, to start your coding for your program. In Java, we start with class. Okay? The keyword is class. So this is the class structure. We have variable declaration. The syntax is data type followed by variable name, data type followed by variable name. This is how we declare variables. Okay, let's say if there is a constant value, so this is how we assign value. This is the assignment symbol. I think this is a very, you are very familiar with this already, right? Have you learned this in your programming fundamental? Have you learned this already, class? Variable declaration?
Yes, madam.
Yes, right?
Sudah.
But this is, you are unfamiliar with public lah, right? This one we'll learn later. Huh? So variable declaration is actually the same as how you declare variable in your programming fundamental. And then this is a constant declaration, also similar. Then this is a comment. Double slash, right? This is a single line comment, multiple line comment. Okay. And this is a Java documentation comment. In Java, the documentation is very important. So before you start to write your Java code, you must have a header first. This is the header. Inside here, you will type who is the author, what is the name of the file, and so on. All the important detail of your class. Methods, set of Java statements that can be included inside Java class, is similar to function procedure operations in a programming language. These are the components in method declaration. We have the modifier, for example, public. We have the return types. This one you are very familiar already. Either void if there is no return value, else you have any data type to declare the return type. We have the method name, parameter list, exception list. You will learn in chapter 5 later on, and also the method body. This is the main method of Java. It is known as a method header or mark the beginning of a method, starting point of an application. Okay. Remember, if you want your program or if you want your Java class to be able to run, you must have main method. Main method is like the on-off switch of your program. If you have main method, then you will be able to execute your Java program. If you don't have main method, it's just a Java library. Okay. And this is fixed public static void main inside the bracket, string, array, arguments, close bracket, open and close curly bracket. Anything you want to execute, put inside here. Is fixed, so you have to memorize public static void main for you to run your code. It is known as a method header. It marks the beginning of your method, starting point of an application. Public static void main. Okay. Any question so far?
No, madam.
No question, eh? Confirm no question, eh? So if I give you quiz, you can answer, right? No respond.
Try our best.
Okay, no quiz, it's just to scare you. But I will give you some question to answer on this Wednesday. We have class on Wednesday, right?
Yes, madam.
Yes, madam.
Yes, madam.
Okay. So I have already made chapter 1 and 2 available in CDOS. 1 and 2. Check. Yes, I've already made chapter 1, 1.1 and 1.2 available in CDOS. Hold on. Share my CDOS first. Okay, there are 3 ebooks that you can look into. Can you access it already? The ebook.
Yes, madam.
Okay, please read the ebook. Can you read? Can you download it and can you see from there? Please read and then, if possible, run all the codes that is available inside there. Yeah, but this is not compulsory lah for you to do revision. The more you do, the more you get familiar with Java. But this LCAT is compulsory. Okay, so today your homework will be page number 3, 4, 5, 6, 7. You're already done, right? Okay, do up until page 13. Can or not?
Yes, madam.
Okay, I will open a thread for you to submit your homework up until page 13. Okay? And second homework. Can you see a link here?
Yes, madam.
Under announcement, there's a link here. Click, you will go to JDK Kit 11 download. JDK means Java Development Kit. JDK. JDK 11. You download accordingly. If you are using Windows 64, I think just Windows x64. It doesn't have the 32-bit one. So you just download, install inside your computer. I will tell you what to do next in the next class. Make sure you download. Okay?
Okay.
Download and install. I will ask you to share screen to make sure that you're already done set up. When I finish the lecture next class, I will need you to show me whether you have already set up the environment or not inside your computer. Why? Because this JDK is very important to make sure that you can run and compile your Java code. If you do not do that, then means that you have to repeat OOP by next semester. All right? So what you need to do today until Wednesday?
Do LCAT
Yes. And?
page
Do
33 until 13.
And then?
and then
Install JDK.
Yes. So these two things lah you have to do. Okay?
Okay, madam.
All
Okay,
right.
madam.
So you have to be independent. I cannot go to your computer, show you one by one, step by step. So you have to depend on yourself. Okay. If you miss out, then I cannot do anything already. Especially when you are going to sit for your final exam, I already cannot help. So it's better that you learn earlier. The earlier that you learn, the more time that you have to do your object-oriented programming is a hands-on subject. You must do the practice, you must do the practical and all the exercises. It's a hands-on subject. If you don't do, if you don't code, if you don't compile the code, if you don't run the code, I'm sure that you have to see me again next semester. Okay? No respond again.
okay.
Madam.
Okay, madam.
Okay.
Okay,
So
madam.
this subject, if you do all the exercises, I'm sure that you can pass. If you want to get A, you have to put more effort. All right? So good luck. Remember to do your homework. I will see you again on Wednesday. Okay?
Okay, madam.
Thank you,
Thank
madam.
you.
Thank you, madam.
Thank you, madam.
Madam.
See you. Bye-bye.
See you. Bye.
Bye-bye.